Students, let us solve now problem number 4 from the miscellaneous exercise of NCERT book. The topic is called permutation and combination. This is a miscellaneous exercise, problem number 4. Now the problem reads like this. If the different permutations of all the letters of the word examination are listed as in a dictionary, how many words are there in this list before the first word starting with E appears? Okay. Now, let us write first of all the word itself, that is called examination. E-X-A-M-I-N-A-T-I-O-N. Okay. Now, if I want to write them in alphabetical order, then the first will come A, and there are two A's in this. So, therefore, AA. Okay. Then A, after A, there will be E, right? So, A, B, C, D, E. Then F, G, H, I. Now, it comes to I. So, there are two I's here. So, let us draw them. So, I, 2I, A, B, C, D, E, F, G, H, I, J, K, L. L is not there. M is there, right? Only one M is there. And there is N. So, there are two N's here. Two N's, right? L, M, N, O, P. So, O is there. Q, R, S, T. So, T is there. And last, X is there. Now, their total number of letters are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, we accounted for all the letters here. Now, if you want to list all the words according to dictionary order, the dictionary will always start with what? The words which are starting with A. Now, suppose we want to calculate all the words which are starting with A, then first position will be occupied by A, and all the remaining position can be occupied by all the remaining letters. Okay. Now, out of 11, A is gone. So, there are 10 letters available, right? So, 10 letters, had they been different, then they could have been arranged in how many ways? 10 factorial ways. But unfortunately, they are not different. Some of them are repeated. Out of that, since A is already taken here, that repetition is not allowed. So, there are two repetitions here, this and this. So, that means it is 2 factorial and 2 factorial because I has repeated twice, N has repeated twice. Therefore, this number if I want to calculate, then it is 10 factorial divided by, so 10 factorial means what? It is 10 multiplied by 9 multiplied by 8 multiplied by, let us call it 7 factorial. Okay. So, now divided by 2 factorial is actually 2. And 2 factorial, because 2 factorial means 1 into 2, which is 2. So, this will be also equal to 2. So, that means this is 4. So, this 4 I am going to cancel with this 8. So, that this becomes 2. Correct? So, now what are we left with? We are left with 9 2s are 18. 18 multiplied by 10. So, 180 multiplied by 7 factorial. Okay. Now, let us see what is a 7 factorial. Let us start with 1 factorial. 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. That means you have to multiply by. So, 4 factorial will be 6 multiplied by 4, that is 24. 5 factorial will be 120. Then 6 factorial, you multiply by 6 here. So, it is 720. And now comes 7 factorial. You multiply by 7. So, this is 7. 7 2s are 14. Carried 1. 7 7s are 49. So, it is 5040. So, this is 180 multiplied by 5040, and this will give you the answer of the problem. Okay, that is the answer to the question. Now, this is A. So, all the words starting with A are over. So, immediately the word which will appear will start from E. And what the problem is, before the first word starting with E, that means these many words will come before the word E. Now, if you want a numerical answer for this, then it is A 0 here and then another 0 here because there are 2 zeros. So, it is 72, correct? And it is 90, correct? So, This is the answer. So these many words can be formed before before the letter starting with the word starting with E appears there. Correct? So that is the answer to this question. Fine. Now, let us have a look at problem number 5. How many 6-digit numbers can be formed from the digits 0, 1, 3, 5, 7 and 9? 0, 1, 3, 5, 7 and 9, which are divisible by 10. Now, that means we have to utilize all the digits given here. So, that means one place is to be filled, 3, 4, 5 and 6. So, there are 6 boxes to be filled. But we want the number to be divisible by 10. You all know that if the number is divisible by 10, then the last place or the units place must be occupied by 0. So, 0 must go here. So, 0 is occupying this. That means this position can be filled in only one way because only 0 can go there, right? So, 0 is out of question now. So, 0 is not in the race as far as other positions are to be filled. Now, this first position can be filled by any one of these 5 numbers. So, first place can be filled in 5 ways. Second place can be filled in 4 ways. Third place can be filled in 3 ways. This is 2 and this is 1. Okay. So, because there are 1, 2, 3, 4, 5 numbers available. So, first place can be filled in 5 ways, 4 ways, 3 ways, 2 ways, 1 and 1, right? So, therefore, the answer is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 multiplied by 1, which is equal to 20 multiplied by 6, and that comes to 120. That is the final answer. Okay. Let us look at problem number 6. The English alphabet has 5 vowels and 21 consonants. 5 vowels and 21 consonants. Now, how many words of 2 different vowels and 2 different consonants can be formed from the alphabet? So, 2 different vowels, that means I have to select 2 vowels from here and 2 consonants from here. The total available vowels are 5. I have to select only 2. Total available consonants are 21. I have to select only 2. Now, that selection can be done in how many ways? 5C 2 ways. I can select 2 vowels in 5C 2 ways. And I can select 2 consonants in 21C 2 ways. But then I have got 4 letters, 2 vowels and 2 consonants, and those 4 lettered word can be permuted amongst themselves in how many ways? 4 factorial ways. So this is how the answer is. Now if I want to find out a numerical answer for this is 5 multiplied by 4 divided by 1 multiplied by 2. This is 21 multiplied by 20 divided by 1 multiplied by 2. 4 factorial we already know it is 24, correct? So that means I am cancelling this 4 and this 2, so this part becomes 10, okay? I am cancelling with this 2, this part becomes 10, so this is 210 and multiplied by 24. So that means the answer is, let us say 2100 multiplied by 24. Okay. So that comes to, those 2 zeros will come here. 24 into 1 is 4. Carry on 2. So 48 plus 2, that gives you what? 5. So the answer is 50400. Okay. So in an examination, the question paper consists of 12 questions. So 12 questions, part 1 and part 2. Now part 2 contains 5 questions and part 1 contains 5 questions and part 2 contains 7 questions. So there are 5 questions available here, 7 questions available. The answer, there you have to solve at least 8. So at least there are 8 questions to be answered. 8 questions. But the condition is that at least 3 from each. At least 3 from each. Okay. Now, at least 3 from each means what? So that means you can have say part 1, you have selected 3 questions. Then you are supposed to select 5 questions from the remaining because total has to be 8. Or you can do this problem by 4 but reduce this by 1, so that is 4. Or reduce this by 5, make it 5, so this will be 3. Beyond that we are not going to go because if I select more than 5 questions anyway cannot be selected because there are only 5 questions in part 1. So therefore 3, 4, 5 and this. So the job can be done either in this way, 3 from part 1 and 5 from part 2, or it can be done in this way, or it can be done in this way, right? So whenever there is or, you will use addition theorem, and whenever there is and, you will use the multiplication theorem. So the answer is 5C3 multiplied by 7C5. 7C5. This total you can check, it is 8. Plus, then increase this 5C4 multiplied by 7C4, right? Then plus 5C5 multiplied by 7C3. Now, this is the answer to your question, right? And this answer can be calculated and you can find out the answer. Okay, that's all. Now, let us do problem number 8, right? Determine the number of 5 card combinations out of a deck of 52 cards if each selection of 5 cards contains exactly 1 king. So the 52 cards can be divided into 2 parts. How many kings are there? In every pack of cards, there are 4 kings. And once you remove those 4 kings, remaining cards are 48. So that this total is 52. Okay. Now, I want to select 5 cards containing exactly 1 king. So exactly 1 king means what? There will be 1 king and I want 5 cards. So remaining cards will be 4. So out of 4 kings, I have to select 1. That can be done in 4C1 ways. And out of remaining 48 cards, I have to select 4. So that gives me 4 upon 1 multiplied by 48 into 47 into 46 into 45 divided by 1, 2, 3 and 4. Correct? So I'll cancel this 4 with this 4, right? And then I will cancel this 3 with 45. So that is 15 here, right? And this 2 I can cancel with this, so it is 23. And if you multiply these numbers, you will get your final answer. Okay? So that is the end of this problem. Now, it is required to sit 5 men and 4 women in row so that women occupy even places. How many such arrangements are possible, right? 5 men and 4 women. Total number of persons are 9. So there are 9 places to be filled. 1, 3, or before that, I think I will do it like this. 1, right? Second place is even, so I'll write it down. This is 3, this is 4, this is 5, this is 6, right? This is 7, right? 8 and 9, correct? So 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? So 9 places are to be filled. Now these places which is second, fourth and all that, these are even places, even, right? And these are odd, okay? These are odd. Now these odd places, how many odd places are there? 5. So there are 5 odd places, right? And there are 4 even places, right? So women will occupy only these 4 places, okay? So, and so the women can occupy, will occupy 4 places. So they can be arranged in how many ways? 4 factorial ways, right? And odd places are available for boys. So those 5 places can be arranged in how many ways? 5 factorial ways, correct? So because there are 5 people and they can be arranged in any way you feel like, right? So among themselves they can be arranged. So 4 factorial we all know is comes to what? 24. And 5 factorial will come, we all know it is 12, right? So this will be 0. So the answer is this. This is 0 and this is the answer. Okay. Now let us look at problem number 10. From a class of 25 students, 10 are to be chosen for an excursion party. So let us write down this properly. So how many students are available? 25. Out of that, only 10 are to be chosen. Out of that, only 10 are to be chosen. Okay. Now, let us see. There are 3 students who decide that either all of them will join or none of them will join. Correct? So either all 3 students are either included or excluded. Correct? Then how many ways this can be done? Now if these 3, remember one thing, that out of, suppose we'll call the students are included, right? If the 3 students are included, they will be subtracted from the total number of students available as well as from the number of selected, because those 3 students will be gone from here as well as here. Why? Because 10 students are not to be selected now, only 7 to be selected. From how many? From 22. So this can be done in how many ways? 22C 3 ways. Okay. And remaining students, so the students and 22C3, that is the total number of ways of selecting, okay, because they are already selected. And or, that means plus, right? So or, they are to be excluded completely. They are not to be included at all. If they are to be excluded, they will be excluded from 25, but not from here. So that means it will be 22C. All the 10 students are to be selected from these 22. Therefore, the answer is 22C3 plus 22C10. Okay. Students, let us do the last problem. In how many ways can the letters of the word assassination be arranged so that all S's are together? Now, if you look at this word SSSS, this letter S comes 4 times. So let us write that first. S, 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 S. That is the first. Now, this will be a combination. So this combination will never part with each other. Therefore, it will be acting like a one object. Okay. So then we have got 2 A's, because there is 1A, 2A, 3A. So there are 3 A's, right? Then we already accounted for S. Then we comes to I. So I will come twice. Okay. So I is accounted for. Then we have got T here, T once, and then O here, and then N here. Okay. So number of words here, A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So we should account for 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think one word is left. N is repeated twice. Correct? That's all. So now this is one word. And suppose I calculate them individually. So it is 2. This is 3. 4, 5, 6, 7, 8, 9 and 10. Correct? So, taking this as one word, one letter, you have got 10 words here. So, 10 words can be arranged in how many ways? 10 factorial ways. But there is repetition. So, A repeats 3 times. Therefore, you will have to divide by 3 factorial. I repeats twice, so it is divided by 2 factorial. Then N repeats twice, therefore you will divide by 2 factorial. Correct? So this is how the answer is, right? Now if you want numerical answer, then you can find out from the book itself. So that's it. Okay? But this is what the answer is. You calculate it and find out. Okay? That's it. So this is the answer. Okay, fine.